Okay, I'm going to start with the session. I gave you a video about 2, 3 days ago regarding the topic 7, and it was about indices and logarithms. So, uh, yes, this is the topic that I spoke about, and I also gave you a quiz where you had to answer 15 questions as well. I hope you had some time to at least try those questions. And anyway, I'm going to go through the session in real quick time so that you can get a basic understanding of how we actually came here. So the topic was actually indices and logarithms, and if you can remember, index is just a mathematical notation to represent a number multiplied repeatedly by itself. So that was the basic definition of index, and I also told you the difference between the index and indices. It's not something that you need to be confused about. Actually, indices is the plural word of index. Okay, I hope you can see my screen, right? Okay, anyway, yeah, index is just a mathematical notation to represent a number multiplied repeatedly by itself, and the word indices is the plural term of the word index. And I said that when you have to write something like 5, now in this example you can see that 5 has been repeatedly multiplied by itself for 6 times. In that case we can write it as 5 to the power 6. This is the notation this is the usual notation that we use, right? Then we also learned about several rules, actually 8 rules related to indices. The first rule, some people call it the power rule, right? In the first rule we had a to the power m and whole thing raised to the power n, and when we have something like this we can simply call it like a to the power m into m, right? So in this example you can see that 2 to the power 2, the whole thing has been raised to the power 3, and it, if it makes sense we can write it as 2 to the power 2 into 3, resulting in 2 to the power 6, where the final answer will be 64. And the second rule stated a to the power m into a to the power n, and it can also be written as a to the power m plus n. Whenever you have a multiplication where the base is common, right? This is we call this the base. When the base is common in the multiplication, here base is a and here also base is a, and you can see a multiplication, right? Whenever the bases are common, you can just uh, add the powers together. We call this power or the index or the exponent. We use all those 3 terms, right? So whenever you have a to the power m into a to the power n, you can write it as a to the power m plus n, and you can see the example here. 3 to the power 2 into 3 to the power 2 can be written as 3 to the power 2 plus 2. I think there should be yes, this is a mistake. It should be 3 to the power 4, and the answer is 381. Okay, and the third rule, a to the power m over a to the power n, resulting in a to the power m minus n. Whenever you have a division, you can just subtract the uh, relevant indices. And in this example, 5 to the power 5 divided by 5 to the power 3, we can write it as 5 to the power 5 minus 3, and the answer is 5 to the power 2, where the final answer is 25. Then when you have the same index or the common indexes but different bases like this, where a to the power n into b to the power n, and you have a multiplication here, in that case you can uh, put the bases in a single bracket like this and raise the whole thing to the common power. Okay, and yes, for the interruption. Yeah, and then we have a to the power n or b to the power n, and here also you can see that the indexes are common or same, but we have different bases. In that case, we can write it as we can write the bases within a single bracket just like this, a or b, and raise the whole thing to the power n. The example is here 10 to the power 6 or 5 to the power 6 can be written as 10 or 5 whole thing raised to the power 6, right? Then you can do the multi or the simplification within the bracket just like this. 10 over 5 should be 2, and the answer is 2 to the power 6. Also, you need to keep in your mind that a to the power 1 equals 1. That is, whenever you have the power of 1 of any given number, the answer is the number itself. Whenever you have 25 to the power 1, the answer is 25. Whenever you have 20 to the power 1, right? Whenever you have 20 to the power 1, you have the answer is 20. In the next rule, we had the zeroth power of any number is equal to 1, right? So whenever you have 2 to the power 0, the answer is 1. Whenever you have 1000 to the power 0, still the answer is 1. 17 to the power 0, answer is 1. And this rule is not applicable for 0. 0 to the power 0 is undefined, so that is a different case. But for any other number, the 0th power is equal to 1. Then we have the negative indices. Whenever you have a negative index like this, you can just write it as 1 over the same thing with the positive index. So whenever you have a to the power minus n, you can write it as 1 over a to the power n, right? If you had 10 to the power minus 3, you can write it as 1 over 10 to the power 3. You can even interchange the denominator and numerator here. For example, instead of this, whenever if you had now the rule stated, if you had to 10 to the power minus 3, you can write it as 1 over 10 to the power 3. You also can write it like this. When you had 10 to the power 3, right, you can write it as 1 over 10 to the power minus 3. So those are the basic 8 rules that I initially discussed, and also then I went on to discuss about the fractional indices. So this is a notation, right? This is a notation, uh, and whenever you come across something like this, you call it nth root of a. This is the root symbol. We use the root symbol, and we call it nth root of a. Okay, say you have 4, let's write 8. We have 8, and we have 3 here. We can call it actually third root of 8, right? So in that case, we okay, yeah, then suppose we have 16 and 4, we can call it fourth root of what, 16. So that is how you denote the fractional indices. And in that also we have two rules, right? The two rules state, the first one states when you have, right, nth root of a, you can write it as a to the power 1 over n. For example, whenever you have, let's say, 125 to the and you take third root of 125, you can write it as 125 raised to the power 1 over 3. Okay, so that's the first rule. And in the second rule we have something like this: when you take the nth root of a to the power n, okay, nth root of a to the power n, you simply get the same number, the same initial number. For example, if you had 5 to the power 4 and you take its fourth root, as per the first rule, we can write it like this. We can write it like 5 to the power 4 whole thing raised to the power 1 over 4, right? Then, as per the power rule or the first rule in the indices that we learned, we can just multiply the powers together. For example, this results in 5 to the power 4 into 1 over 4, and these 4's cancel out, resulting in 5 as the answer. So those are the two rules of the fractional indices. And then I also need to emphasize the fact that whenever you have 2 here, whenever you take second root or the second root, we call it square root. And usually we do not write this 2. Whenever you have 2 here, we usually do not write 2. So if you have something like this, then simply the answer is 2, because uh, even though we have 2 here, we do not write it usually, right? So that's something I wanted to emphasize. And whenever you have 3 here, right, you have 3 here, we call it, what do we call it? We call it cubic root, right? So whenever we have 2 here, we call it square root, and whenever we have to take the third root of any number, we call it the cubic root. Okay, then we learned bit about the logarithms, and I wanted to tell you about the difference between the indices and the logarithms. Okay, and as you can see here in this definition, logarithm is another way of writing index. It's not anything that is completely different from indices. It is just another way of writing logarithms. That is all. So that is all what you need to keep in your mind. Okay, so you can see that when you have y equals a to the power x, we can write it as log of y to the base a equals x, where a and y are natural numbers. So the most common example that you can remember is, let's say you have 8 equals 2 to the power 3, then you can write it like this. Then you can write, whenever you have 8 equals 2 to the power 3, you can write it like log of 8 to the base 2 equals 3. You see that this 8 comes here, this 2 comes here, and this 3 comes here. Okay, so this is just another way of writing the indices, and that's all you need to keep in your mind. Okay, and we discussed two examples. Okay, and also then we needed to discuss about five different rules of logarithms. The first one stated log of xy. You can see a product here, and we usually call this the argument. Let's see. when we when we have something like this, log of, what was the base there, a, log of xy to the base a, we can write it as log of x to the base a plus log of y to the base a. You see that we use the same base here. When we had base as a here, we use base as a here and here as well. And you, whenever you have something, whenever you have a product here, you just write it as an addition. Okay. And also you need to keep in your mind that we call this particular part argument. So this is not something that will be asked in the examination. So just to keep in your mind, we call this the argument. So whenever you have a product in the argument, you just expand it in the form of additions, where you write the log values of the respective terms of that product. Okay, and this is the first rule. And similarly, we had the second rule, in which it stated log of x over y x to the base a, we can write it as log of x to the base a minus, right? Because we have a division here, we use the minus here, or the subtraction here, log of y to the base a. Okay, and also then we had a third rule. It states log of x to the power k to the base a is equal to k into log of a, log of x to the base a, right? You can see that this k, whenever you have a power here, okay, whenever you have a power in the argument, you can simply bring this power to the front of the uh, term here, right? You can see that this k comes to the front and it comes here as a product here, as a multiplication, k into log of x to the base a. So that is third rule. And then we have the fourth rule, log of a to the base a. Whenever you take the logarithm of a particular number and to the base of that particular number itself, you get the answer as 1, right? Log of a to the base a equals 1. I want to show you how this happens actually. Let's come write it like this. Now I told you that the logarithms is just another way of writing the index. So imagine we have log of 3 to the base 3, okay, and we need to find the value of this, okay. And as you can see here, what we had in the previous example was that uh, when we had log of 8 to the base 2, the answer is 3. And when we want to convert a logarithm into the indices, what we usually do is we write this 8 as it is, and then we take this 2 here, right? Then the 2 becomes the base and the previous answer becomes the index. So that is how we convert the logarithm into the indices. So we can do the same thing here as well. Instead of this, we can write 3 as 3 to the power x. And we know that whenever we have an equation like this, where the bases are similar but the index, but we have different indices, and in this case we have x as an index but x is a variable. So in that case, we also know that 3 is same as 3 to the power 1 and 3 to the power x. We have the same base here, and in that case we can equate the indices, resulting in x equals 1, right? So therefore with that we can learn that log of 3 to the base 3 is equal to what? 1. And generally we can write log of a to the base a equals 1. Then the final rule, you can justify this one in just like we justify this one as well. So log of 1 to the base a is always equal to 0. Okay, so then we discuss several examples. And then mostly importantly, I taught you about the change of bases. So this is a particular equation which you will need to use in the examination, probably at least 1 or 2 times. So it's really important that you keep this equation in your mind when going to the examination or when facing any question that is related to the indices and logarithms in the examination or in the quiz or whatever form of exam that you face. Okay, you can see that I'm not going to do the proof again. You can see that log of b to the base a can be written in another base like this: log of b to the base c over log of a to the base c, right? And if you have a hard time remembering this particular equation, you can do it like this. You have log of uh, b to the base a, what was it? Yeah, and we need to convert this to a different base, and I'm going to convert it to base c. In that case, you can write it like this: log of, you can see that at the top we have b, and at the bottom, even though it's small, at the bottom we have a, right? So in the numerator, we write log of b to the to our new base, log of b to the base c, and over log of a to the base c. So that's simple and simple as that, and you need to keep this in mind. And you do not have to remember this particular proof. You do not have to remember this particular proof, but it's if it makes you better, you can remember. You can just see how this how we actually get this particular equation. Okay. Then we spoke about the natural logarithms, and I also told you about why it is a natural logarithm, and also I emphasize the fact that the number e, is a an irrational number, so we do not have an exact number. And I told you about, or I taught you about two different approaches for calculating the value e, and it's not going to be tested in the examination, so you do not have to keep any of this in mind. Okay, just remember that there is something called natural logarithms, and there is a number called e, and its value is approximately 2.718, and it goes on forever. Okay, and also I need to emphasize the fact that in the exam, whenever you need to keep this in mind. Okay, whenever you have something called lnx in the exam, this is simple as log of x to the power x to the base c. Whenever you have lnx in the examination, this is same as log of x to the base e. Okay, that is something you need to keep in your mind. Okay, and you do not have to remember how we calculate e. Those things are not tested in the examination, so you do not have to keep them in the mind. Just keep in the mind that lnx is written as log of x to the base e, and also when we take e as the base, we call it a natural logarithm. Okay, instead of, now in our previous examples you saw that we took different bases. We took base as 10 to different numbers. Whenever we take e as the base, we call it a natural logarithm, and you need to also keep in mind that the rough value of e is 2.71. Okay, there's no exact value because it is an irrational number, just like pi. Then I taught you about the graphs and how we can draw this graph. And finally, I gave you a quiz where we had to answer 15 questions, and I hope you answered all those questions. And I'm going to discuss these 15 questions as soon as possible and see how we can tackle them. Uh, in the chat, you can raise any question if you had any question regarding to the quiz. Did you have any problems related to the quiz? I mean, any was it easy or was it difficult for you? You can respond in the chat. I would really like it if you can speak, but all of you have actually disabled the microphones. Were the questions easy or were the questions difficult? Come on, just say at least yes or no. I want to emphasize the fact that these are the type of questions you might be getting in the examinations, and you haven't actually been tested this particular section in the introductory mathematics part. Okay, this was previously in the semester 2 mathematics module, mathematics for computing 1. Okay, and now we have moved that particular topic from that to from mathematics for computing 1 to this introductory mathematics section. So these are the sort of questions that you might be getting in the examination, so you need to be familiar with the uh, type of questions that you will be asked, and also you need to be familiar with how you can actually solve these questions. uh, since none of you actually answered in the chat, I'm going to go ahead and thank you for the answer. Actually, Suji says some questions were able to do. Okay. And yes, there can be tricky questions here, and I'm going to discuss them more so that you don't have to worry about them. And I would like it if, I mean, if you can mention any at least five, yeah, let's say you had difficulties in solving at least one question. I would like it if you can at least mention the question number in the chat, because that way I can get to know the particular areas where you can have you will have to be tricky. So I would like it if you can at least mention any question number that you found any difficulties in dealing with. 3. Okay, thank you. Others? Hmm, others do not seem to be responding. 8 and 9, thank you. 8 and 9, thank you, thank you. Okay. Okay, all the, yes, both 3, 8, and 9, all three questions are related to indices, right? Not logarithms. Cool. Can you all see my screen? Can you all see the questions? I mean, there can be students who are viewing from the smartphone, and I hope that you can see my screen well now. Okay, question 8, thank you. 8, 9, 10, 8. Okay, 8, 9, and 10. Cool. Okay, I'm going to start discussing, so we'll have time. And let's start with the first one actually. Anyway, the first one is we have been given a quotient or a division. Okay, in the numerator we have 16 to the power 1 over 2, 16 to the power 16 to the half power. Okay, 16 to the half power, or we can write it as, if you can remember, this is same as root 16, okay, into 2 to the power 2 over 16 to the power 3 over 2 into 2 to the power 0 is equal to, and we need to simply find the answer for this particular uh, fractional one. Okay, so we have fractional indices here, and also we have to apply the different logarithm index rules here. So let's see how we can do it. Okay, and I'm going to erase all these and see what we can do. Okay, I'm going to do the question now. Sorry about the delay. uh, okay, the question stated like this: 16 to the power 1 over 2 into 2 to the power 2 over 16 to the power 3 over 2 into 2 to the power 0. Okay, so this is just an application of the rules of indices. And if you can remember, we had something like this. We had a to the power n over a to the power m. We can write it as a to the power n minus m. Okay, so this is the same rule that we are going to apply here. We can write it like this: 16 to the power half over 16 to the power 3 over 2 into 2 to the power 2 over 2 to the power 0. Okay, we can write it like this. I mean, this is a multiplication, so you can arrange it any way you want uh, while adhering to the rules of mathematics or the multiplication. So you can see that uh, we have 16 to the power 2 and 16 to the power 3 over 2 here. So uh, you can write it, you can even write it like this. Okay, you can write this as, when we have n over a to the power n over a to the power m, you can write it like 1 over a to the power m minus n, right? So this is same as uh, taking the negative index. Okay, you can remember that we had we could write a to the power n as 1 over a to the power minus n. So I just wrote it like this, and we can apply the same thing here. uh, we have 16 to the power 1 over 2 and 16 to the power 3 over 2, and rather than writing it like this, I'm going to write it like this: 1 over 16 to the power 3 over 2 minus 1 over 2, okay, into 2 to the power 2, and this is just 0, so this is 1. I'm going to keep it as it is. Okay, so we have 2 to the power 2 over 16 to the power 3 minus, we have a subtraction of two quotients, and in that case we have the same denominator, so we can just simply subtract 1 from 3, and we have 2 over 2. So that is what, 1, 2 over 2, right? 2 to the power 2 over 16 to the power 1. Answer is 4 to the power 4 over 16, or we can also rewrite it as 1 over 4. Okay, And what are the answers we have? 1 over 4, right? 1 over 4 is an answer. Okay, then take answer 1, 2 to the power 2. Okay, 2 to the power 2 over 16 into 2 to the power 0. Still the answer is this, right? In A we had 2 to the power 2 over 16, 2 to the power 0. Still you get 2 to the power 2 over 16. Still answer is 4 over 16. So A is correct. Also we found that B was also correct. What about C? 4 to the power 2 into a half, raised to the power half into 2 into 2 to the power 2 over 4 squared raised to the power 3 over 2 into 2 to the power 0. Now you need to just simplify this and see whether it still gives us the exact answer that we got for answer A and B, right? What we are trying to see is whether all the 5 answers are same or not. So in an examination like this where you have to have more than one answer for questions, you need to just check all the 5 answers and see you can find an answer in each of the choices. So I'm going to go with the C and see if I can find an answer there. So it states 4 square to the raised to the power half, right? In C we have 4 square raised to the power half to the power 2, 2 to the power 0, and here we have right. So is this same as the one that we had earlier? Yeah, 4 squared still means 16. 4 squared still means 16, and this is same as this. So we do not have to just simplify this, and even if you simplify this you will still get this answer. Okay, so this still the answer is 1 over 4, and we can say that answer C is correct. And answer D states 1 over 2. No, we had the answer as 1 over 4. And answer E states 1 over 6, no, 16. No, we have the answers 4 over 16, or rather 1 over 4. So the answers are A, B, and C. And if any of you had any difficulties in understanding the question or the answers, please let me know in the chat here. Okay, please let me know in the chat so that I can re-elaborate it and see trying a different approach for teaching you that. Okay, now let's move on to the question 2. I hope all of you understood this. Okay, and now moving on to the question 2, we have log of 54 to the base 10 plus log of 5 to the base 10 minus log of 3 to the base 10, and it is multiplied by 3 at the front and is equal to, we have to find an answer for this one and see if we can find a value here. So I'm going to write it and see what we can do. So the questions 2, okay, we have log of 54 to the base 10 plus log of 5 to the base 10 minus log of we have 3 here, log of 3 into log of 3 to the base 10. Okay, what we are going to do is we are going to simplify this, and you can see that we can write it as log of 5 log of 54 to the base 10 plus log of 5 to the base 10 minus, we saw that in logarithms when you had log of x to the power k, you like this, we could bring this the power k to the front like this, k into log of x to the base a. Okay, so that is the same thing that we are going to do here. Rather than keeping 3 here, we are going to bring this 3 as a power here. We are going to bring this here. So in that case, we can write it as log of 3 to the power 3 to the base 10. And you can see that we have 10 as the base in all 3 terms. Okay, so we can write it as uh, a product or a division in the, so okay, I'm going to take these two first. So we can write log of 54 to the base 10 and log of 5 to the base 10 like this, log of 54 into 5 to the base 10, and I'm going to keep the other term as it is. Can write it 9, not 9 actually, 27. 3 to the power 3 is 27. Okay, I hope you understood what I did here. What I did was we had a logarithm rule like this, log of xy to the base a can be written as log of x plus log of y to the base a. Okay, so this is something like we have in the left side, and we are going to do it in convert this into this form. So that is what I did here, log of 54 into 5 to the base 10 minus log of this is the third term that we kept it as it is. And also we need to keep in mind that we can convert this particular subtraction as a division while we put this back into the logarithm form. Okay, so rather than this 5, we have a subtraction here, so we take the division and write 27. Okay, now you can see that we can we can do the simplification inside this bracket. 54 over 27, the answer is 2, and 2 into 5, 10. Okay, I'm sorry about the way I'm writing. Okay, now we have log of 10 to the base 10. So what is log of 10 to the base 10? Still the answer is 1. Okay, we are taking the logarithm of a particular number to the same base. Log of 10 to the base 10, the answer is 1. So what is the answer we have here? We have answer as E. Are there any other answers? No, our answer was log of 10 to the base 10. So this is log of 90 to the base 10. No. Log of 30 to the base 10. No, it's not the answer. And log of 10 to the base 10. Is this an answer? Is this an answer? Yes, we had log of 10 to the base 10. And it still is. So C is an answer. Okay. Log of 1 to the base 10, no, it's not an answer. And 1, just 1. Log of 10 to the base 10 is also equal to 1. So we have two answers here, C and E. Okay, now I'm moving. I hope that you had understood what I mentioned there. And I'm moving on to the question number 3. This is a basic indices problem, and we have 27 into x to the power 27 over 64 into y to the power 63 is equal to. Okay, now whenever you come across a question like this, just don't panic and try to solve the question and see if you can go some, or you can get some particular answer. It's not going to work. Just look at all the 5 answers and see if we see if you can convert this one into one of the answers given here. Okay, so when I tried to do this question, the first thing I noticed was that all three answers had 3 as the power. Okay, see 3, 3. On all 5 answers, you had 3 as the power. So you need to be smart and try to convert this into something like this, where you have 3 as the power, something you have some term here, and whole thing is raised to the power 3. So your end goal must be to convert this to a form where you have 3 as the power. Okay, so if that makes sense, what we are trying to do is we are trying to convert this into a power of 3 and write something inside. So I'm going to do the third question now, and it had 27 to the 27 into x to the power 27 over 64 y 63. And when you see 27, you should see you should remember something that is related to 3. And whenever you see 64 also, you should remember that it's got something to do with 3. So I'm going to write 27 as you know that 3 into 3 into 3. Still we get 27 and x to the power 27. We know that 4 into 4 into 4, that is what I said about 3. Okay, 4 into 4 into 4, that is 4 is repeatedly multiplied by itself for 3 times and into y to the power 63. So this is 3 to the power 3 x to the power 27 over 4 to the power 3 y to the power 63. Okay, then uh, I'm going to write it like this. I'm going to convert this one into so now what we are trying to do is we are trying to do something like this. We have to write something inside here, and our that should be raised to the power 3. Okay, then rather than writing 3 to the power 3, we can write 3 here and 4 here. So whenever we multiply this one, whenever we take the power of this one, we have 3 to the power 3 and 4 to the power 3 into uh, I'm going to write 27 like this, x to the power 9, right, over, and y as y to the power 21. See, the whole thing is raised to the power 3. Now you can see that 3 x to the power 9 over 4 over y to the power 21, and you raise it to the power 3, and then you still get as 3 to the power 3 x to the power 9 into 3 over 4 to the power 3 into y to the power 21 into 3. Okay, now you get 3 to the power 3 x 27 over 4 to the power 3 y 63. Okay, now you can see that we have the same one as here. So this is this is the particular answer that we are looking for. Okay, so now see whether we have an answer like this. 3 to 9. Okay, how it comes 9? You take it like this. I hope you understand how we wrote 3. I'm going to write it like this. Okay, 9 came here as we had 27 here as the power. Okay, and I'm trying to put it into a bracket and raise whole thing to the power 3. Okay, so in order to have 27 here, you need to have 9 here. See, 9 into 3 is 27. I'm writing it like this. 3 to the power 3 x 27 over 4 to the power 3 y 63. So this is what we have, and we are trying to write it like this. We are trying to convert this. We are trying to put this in a bracket, okay, and raise the whole thing to the power 3. Okay, then we know that when we have something like this, this is a rule, okay. When in the power rule we have, when we had a to the power m and that is raised to the power n, we have a, okay, this is the rule that we had. So like that we can write 3 over 4. When we take, or when we expand this, we get 3 to the power 3 over 4 to the power 3. Then for writing x, we need to write some kind of a power here. Also for y, we have to write a power here. And in the answer we have x to the power 27 and y to the power 63. Okay. Now based on this rule, you know that you just take the multiplication of the powers to get this particular one. So you need to have something. Let's say we call it a, and here we have b. Okay. Now you need to find values for a and b such that you get this one. Okay. In that case, you can see that 27 is equal to a into 3 and 63 is equal to b into 3, right? So we get uh, a equals to 27 over 3 is 9, b equals 63 over 3 as 21. If did you understand, Suji? Okay, thank you. So that is how we do it, and I'm going to move to the fourth question. Which of the following are the solutions of 2 into log x plus 2 of 4 equals 1 plus log of x plus 3 to the base 4? So this is a question, and it might take some time for you in the examination, and I'm going to do it now. I'm going to erase all this. Okay, yes, I'm going to do the fourth question now. Okay, the fourth question: which of the following? This we have a logarithm equation here, and we need to find, whenever you are asked to find a solution where the equation consists of a variable, and in this case we have x as the variable. Okay, in this case we are simply trying to find the value of x. Okay, we are trying to find the solution, and what we are essentially trying to find is the value of x. Okay, how are we going to tackle this kind of a question? That's the question. Okay, what we have to do is we have 2 into log of x plus 2 to the base 4. Okay, plus, no plus, just equal 1 plus log of x plus 3 to the base 4. right? So what we are trying to find the value of x. So how are we going to do this? You know that when you have a multiplication here like this, where you have a constant value at the front, you can take this to the take this as a power here. So I'm going to take it as a power here. Okay, so if that makes sense, log of x plus 2 raised to the power 2 to the base 4 equal to is equal to 1 plus log of x plus 3 to the base 4. Okay, now I'm going to keep 1 here and uh, take this log of x plus 3 to the base 4 to the left side of the equation. So log of x plus 2 to the base 2, I'm sorry, log of x plus 2 raised to the power 2 to the base 4 minus log of x plus 3 to the base 4 equals 1. And this is a usual subtraction logarithm question that we faced earlier as well. So we can rewrite this as log of x plus 2 raised to the power 2 over x plus 3. Okay, so this is a single, so this is the argument we have of this logarithm, and where our base is 4 and 1. Okay, now how many ways are there we can write 1? We know that log of a to the base a is 1. Okay, so we can put any number here for a and get answer as 1. So what I'm trying to do is I'm trying to write log of 4 to the base 4. I'm sorry. Okay, log of 4 to the base 4, right? You see that now we have logarithms in the both sides of the equation symbol. Okay, when we have something like this, we can just equate, or we can write it like this. We can forget the logarithm part, because remember that we have the same basis. Okay, that is why we are forgetting the logarithm part. We are neglecting the logarithm part because we have the base 4 as the base as the 4 in both sides of the equation. So we can write it as log x plus 2 to the power 2 over x plus 3 equals 4. I hope you understood what I did there. And now what you are going to do is simply uh, get the answer of x in this equation. So I'm going to expand this as x plus squared plus, uh, let's write it like this. So this is x plus 2 into x plus 2. X plus 2 is repeatedly multiplied by itself for 2 times over x plus 3 equals 4. Then we can expand this as x into x squared okay, x into 2, 2x, 2 into x, 2x plus 4 over x plus 3 equals 4. Okay, so this is x squared plus 4x plus 4, and we can take this one here. Okay, 4 into x plus 3, and this is 4x plus 12, x squared plus 4x plus 4. You see that 4x to 4x are cancelled out here, and x squared is equal to 12 minus 4, where the answer is 8. Okay. I want to let you know something here. When you have something like this, say x squared equals 9. Okay. Now you know that the square root of 9 is 3. So you might be tempted to write it like 3. But the reality is that when you have x squared, when you have a variable like this, where we have x as the variable, you write the answer as not just 3, you write it as plus or minus 3, because we have a variable here. Okay, we have x, we do not know the value of x. What we are essentially trying to find is the value of x. So we are writing the values of x as plus or minus 3. So 9 can be written as 3 into 3 is 9. Also minus 3 into minus 3, still the answer is 9. So that is why we have two answers here. We have plus or minus 3. So just like that, we have x squared equals 8, and we have as x is equal to plus or minus 8, root 8. Okay, and we can write root 8 in another way. Now we need to first find whether root 8 is an answer. No, root 8 is not given as an answer. So we need to somehow find or write this in another form, that is equal to root 8. You know that 8 is equal to 4 into 2. This is still valid. Okay, and now you can just write it like this. 4, you can write it like this. You can just separate the root symbols and write it like this. Still you have the root 4. Root 4 is 2, and the root 2 is root 2. So the answer is plus or minus 2 root 2. See if we have an answer here. Yes, we have B and D as the answers here. Root minus root 2, no, it's not an answer. 2, not an answer. Root 2, it's not an answer. Our answers are B and D. Okay, thank you. And I'm going to move to the fifth question now. Log of 8 to the base 4. Fifth one. Log of 8 to the base 4. I'm just going to simplify this. You can write it as, how are we going to write it? What are our answers? Oh, we have several answers. Okay, I'm going to write it like this. 8 can be written as 4 into 2. Right? Now we can write it as log of 4 plus log of 2 to the base 4. We know that log of 4 to the base 4 is 1 plus, and log of, what is this? Log of 2 to the base 4. You can write it as log of 4 root 4, okay, because root 4 is 2. Now we have, we know that we can bring this particular power to the front, where we can write it as 1 plus half to log of 4 to the base 4, and we know that this particular one is equal to 1. So our answer is 1 plus half into 1, and answer is 1.5. So is our answer 1.5 there? Yeah, answer is true. So are we going to go to the next question and see if we have different, see, are we going to go to the next question and thinking that we have finished the question 5 here? No, we are going to see other options as well and see if we can find any answers there as well. Now see, answer B is log of 4 to the base 2 minus log of 8 to the base 2. You are going to have to find or evaluate these as well. Okay. In answer B, we have log of 4 to the base 2 minus log of 8 to the base 2. Log of 8 to the base 2, right? Uh, I'm going to write this in, see, we can write it as log of 2 squared to the base 2 minus log of 2 to the power 3, like this. If you have any questions, please place it in the chat and I will be able to see that. So this is 2 minus 3 and the answer is minus 1. So this is not an answer. We have C, log of 2 to the log of 4 to the base 2 and log of 8 to the base 2. C, log of 4 to the base 2 log of 8 to the base 2. So this is again 2 over 3. Still the answer is not 1.5. It is not equal to 1.5. Then again we have 2 over 3. Still no. Then we have answer E, log of 8 to the base 2 and log of over log of 4 to the base 2. CE, log of 8 to the base 2 over log of 4 to the base 2. We have 3 over 2 here. If you had any questions regarding how I got this 3 over 2, please let me know in the chat. Answer is 1.5. Now we have 1.5 as the answer, so E is an answer. Also A is an answer. Then our answers are A and E. Okay, I'm going to go to the sixth question now. Sixth question, we have minus 3 plus log of 120 to the base 2 minus log of 5 to the base 2 is equal to, and we have to find an answer. So what are the answers here? What is the answer for the sixth one? You can hear me, right? What is the answer of sixth question? Okay, B. Others? One says answer is B. Others? Didn't you do? Okay, another one says B and C, and another one says B. Okay, what are the answers? B. Okay, I'm going to do the question now. Two students said the answer B, and another one said the answers are B and C. So the question is minus 3 plus uh, minus 3 plus log of 120 to the base 2 minus log of 5 to the base 2. Okay, now we are going to simplify this, simple as that. See what our answers are. Our answers, we have base 2 here, we have base 2 here. Yeah, I'm going to just write this in base 2. So minus 3, we are going to write it as it, and we can write 120 in a different way. We can write 120 as how? 24 into 5. 24 into 5 base 2 minus log of 5 to the base 2. We can expand this, log of 24 to the base 2 plus log of 5 to the base 2 minus log of 5 to the base 2. You can see that log of 5 to the base 2 are cancelled out here, right? And then we get minus 3 plus 20 log of 24 to the base 2, and we can write 24 as 8 into 3. And I'm just doing it a little quicker. uh, Minus 3 plus, we can also rewrite it as log of 8 to the base 2 plus log of 3 to the base 2. So we have minus 3 plus, we can write 8 as 2 to the power 3 to the base 2 plus log of 3 to the base 2. Okay, now we have minus 3 plus, we can bring this 3 here, and log of 2 to the 2 1 plus log of, okay, now we get minus 3 plus 3, and answer is log of 3 to the base 2. Answer is given as B, log of 3 to the base 2. Log of 8 to the base 8, no, it's not an answer. So A is not an answer. Is C an answer? Log of 2 to the base 3, and the whole thing is raised to the power minus 1. See, let's see. We had, the answer is in B. The answer is log of 2 to the base 3 minus 1. Now when you have minus 1, you can write it like this, log of 1 over log of, see the negative index here, okay? Minus 1 is applied to the whole log term, not just 2, but the whole log term, okay? The minus 2 is applied to the whole term. Therefore, you cannot bring this minus 1 to the front. You need to keep in your mind that, okay? You cannot bring this minus 1 to the front when you have a bracket for the whole term. If you had log of 2 to the minus 1 just like this, then you can write it as, then this is perfectly acceptable, okay? But when you have log of 2 to the base 3 and you take the minus or negative 1 power of the whole thing, you cannot write it like this, okay? You need to keep it in your mind explicitly. Please do not do this mistake, okay? Therefore, since this is like this, and we can just this just acts like the normal power rules that we learned earlier. So we can write it as 1 over log of 2 to the base 3. Okay, now still is our answer. Same, our answer was log of 3 to the base 2. Now we have 1 over log of 2 to the base 3. So this is, now you need to see, or you can try to convert this log of, or this base 3 into base 2 and see if we can still get the answer. Because we had answer in base 2. Okay, now you need to remember the base conversion equation. I'm sorry about the interruption there. Okay. Okay, I'm trying to write the base conversion equation here. So if you can remember, base conversion equation was log of a to the base b can be written as log of a to the base c over log of b to the base c. So if that is the case of the equation, then we can rewrite this as 1 over log of 2 to the base 2 over log of 3 to the base 2. So this results in log of 3 to the base 2 over log of 2 to the base 2. We know that log of 2 to the base 2 is 1. So log of 3 to the base 2 is an answer. So this is an answer. This is an answer. So B is an answer. Now you need to see the answer C. A log of 10 to the base 2 and log of and then you multiply the whole thing, log of 3 to the base 10. Again, you can do a base conversion and see if we can get the same answer as B or C. This one is C, right? Anyway, now I'm trying to find D. We have log of 10 to the base uh, log of 3 to the base 10, log of 3 to the base 10. So I'm trying to convert this particular one into base 2, the right whole thing in the base 2. So we have already base 2 here, right? And I'm trying to convert this to base 2. We can write it as log of 3 to the base 2 over log of 10 to the base 10. I'm sorry, the base 2. Okay, this one cancels out, and again we get the answer as log of 3 to the base 2, right? So D is also an answer. So and when I asked the answers for this question, two students said only the answer B is true, and one said B and C are true. And if you got only B as the answer, then you will get only 1 over 3 marks for this question. Okay, if you got B and C, then you will get only uh, 2 over 3 marks. And if you got all three answers correct, B, C and D, then only you will get the full marks for this answer. So you need to be very careful. Okay, I'm going to the seventh question now. Which of the following is equal to x to the power 2 over 3? X to the power 2 over 3. It's a simple question. Uh, so the first one we have x to the power 1 over 3 and whole thing is raised to the power 2. This is the power rule. So we have a as x whole thing is raised to the power 2. So this is the power rule, and we can just write it as 1 over 3 into 2. So we have x to the power 2 over 3. Is A an answer? Yes, A is an answer. Is B an answer? Here we get x in x to the power 1 over 3. Whole thing is raised to the power again 1 over 2. So B, A was an answer. B, x 1 over 3. Whole thing is raised to the power 1 over 2. So we write it as 1 over 3 to 1 over 2, and we have x 1 over 6. So this is not an answer. Uh, Answer C is also the same. We get x to the power 1 over 6 as the answer. Answer D. See the answer D. X squared raised to the power. I'm sorry. We take the third root or the cubic root of x squared. C. X squared, and we take its cubic root. So we can write it as x squared raised to the power 1 over 3. You can write it as x like this. So answer is this, and this is an answer. So answer C is correct. I'm sorry, answer D. Answer D is correct. Did I? Right. C was actually again incorrect, and this is D. And I'm going to see the answer E. Answer E is x to the power 4 over 3 raised to the power 1 over 2. X to the power 4 over 3. Whole thing is raised to the power half. Again, x into 4 over x to the power 4 over 3 into half. You get 2 over 3. So E is an answer. Okay. So answers are answers are A, D, and E. A, D, and E for the second question. So I'm going for the 8th question, and this is a question that you wanted clarification, right? So answer 8. Question 8 actually. Question 8. We have x squared into y z cube over x cube y squared z. So this is just a index question. You can write it as x to the power 2 minus 3, because I am bringing this 3 to the up. And y, we have 1 here. So 1 minus 2 z, we have 1 here. Okay, so minus 1. What is it? X to the power minus 1 into y to the power minus 1 into z to the power 2. So we can put this to the denominator, and in that way we get z squared over xy. If you had any doubts regarding the answer, regarding my workflow there, please let me know in the chat. So our answer is z squared over xy. Is there an answer like that? Uh, I think I have made a mistake there. I think there is no answer there. Actually, I've written a different answer here. I'm sorry about that. And yes, the answer for this one is z squared over xy. I'm sorry about the non-existence of answers here. Okay, I will fix this and re-upload it. Okay, I'm moving on to the ninth question now. So this is the answer that should be there for the 8 questions, and if you got it right, and yes, this is the answer. Okay, ninth one. Ninth question. Evaluate 4 into a to the power 6, b into a to the power b into b raised to the power 4 and into c raised to the power 2. Whole thing is raised to the power again 1 over 4, and we have been given values for a, b and c, where a is 2, b is 3 and c is 9. So you just need to substitute these values and evaluate the answers. 9. 4 a to the power 6, b to the power 4, c to the power 2, and the whole thing is raised to the power again 1 over 4. Right? A is 2, b is 3 and c is 9. So I'll just write the values there. So instead of 4 you can write 2 squared, right? Instead of 4 you can write 2 squared, and for a we have 2, so instead of a you are going to write 2, and a is raised to the power 6, so 2 is also then raised to the power 6. And then we have b, the value is 3 to the power 4. Then c, what is c is 9, right? 9 can be written as 9 is same as 3 to the power 2. So I'm going to write it as like this, 3 to the power 2, and that is raised to the power 2. Okay, so you need to be careful regarding the putting the brackets there. Then we have 1 over 4. So you see that 2 to the power 2 and 2 to the power 6, you can just add the indices there. So that gives us 2 raised to the power 2 plus 6 into, here we have 3 to the power 4, and here we have 3 to the power 4 again. And again the whole thing is raised to the power 1 over 4. So 2 to the power 8 to 3 to the power what? 4 plus 4, 8. And whole thing is raised to the power 4. This is a power rule. We can write 2 to the power 8 into 1 over 4. Again 3 to the power 8, 1 over 4. We have 8 over 4, 2 to the power 2 into 3 to the power 2. And the answer is 4 into 9, 36. Right? Okay, so that is the answer for the 9th question. The answer is 36 and the answer is B. Answer is B. Okay, now I'm going to the 10th question. So the 10th question is a question that was raised by the question. So if you answer the 10th question, could you please mention it in the chat, the answers for the 10th question. Answers for the 10th question. Okay, one says C and E. Others, okay, 3 students say C and E are the answers. Okay, we do not have much time, and let's see the answers for the 10th one. So the 10th question states we just have to find the value of minus 2 plus log of 20 to the base 2. Minus 2 plus log of 20 to the base 2, right? Now I'm going to find the value here, so we can write minus 2 plus Instead of instead of 20, you can write log of 4 to 5 and to the base 2. You get minus 2 plus log of 2 to, right, minus 2 plus 2 into 1. Please let me know if you have any questions regarding the simplification here. And the answer is, these two are cancelled out. Answer is log of 5 to the base 2. So this is the answer. And we need to find, we need to go through each of the choices in the answer sections and see if we can find the answer similar to log of 5 to the base 2. The first one is log of 3 to the base 2. No, it is not equal to log of 5 to the base 2. So the A is not an answer. Now we need to find the value of value of B. Okay. Now see that you see that our answer should be in the base 2. Let's try to convert this answer B. Answer B. Now answer B, we have log of 2 to the base 10 into log of 3 to the base 10. So I'm trying to convert this into base 2 and see what we can do. Log of 2 to the base 2, log of 10 to the base 2 into log of I'm sorry about that. Log of 3 to the base 2 over log of 10 to the base 2. So can you do any simplification here? No, there is no any simplification that you can do here by and go forward with this particular answer. So B is not going to be an answer that will be equal to log of 5 to the base 2. So I'm going to term B as not an answer. C. What is C? Log of 5 to the base 2. So that was, yeah, that was the exact answer we had here. So C is an answer. And then we have to evaluate the value of 2. We'll evaluate the value of D. Log of 5 to the base 2 over log of 10 to the base 2. I'm sorry, that's not. In C we had in D we had log of 3 to the base 10, right? Log of 3 to the base 10 over log of 2 to the base 10. I'm going to convert this to log of base 2. So I'm trying log of 3 to the base 2 over log of 10 base 10 over log of 2 to the base 2 over again log of 10 to the base 2, right? Then we have log of 3 to the base 2 over log of 10 to the base 10, log of 10 we have this cancelling out. We have log of 3 to the base 10 because this one is 1. So C gives log of 3 to the base 2 and this is not an answer. Now D. What was it? Okay, this is B. C was an answer, and then the D. This is D, right? This is D. So D was not an answer, and then we have to find the value of E. E is log of 5 to the base 10 and log of 2 to the base 10. Log of 5 to the base 10 over log of uh, 10 to the base log of 2 to the base 10, right? 2 to the base 10. We can just convert the logarithm bases, and I think this is an answer. Log of 5 to the base 2 over log of 10 to the base 2 over log of just simplify this. What do we write there? 10 right? These two cancel out. This is 2, right? So this is 1. So the answer is log of 5 to the base 2, and our original answer was also that log of 5 to the base 2. So this is an answer. So the answers are C and E. Yeah, C and E. Then 11. What is the solution of half raised to the power 2x plus 1 equals 1? 11th. We have to find the solution of, again we are asked to find a solution, and we have a variable of x. So when we ask to find a solution, it just asks us to find the value of x. In that case, we have 2x plus 1 here and equals 1. So if you come across a question like this where you have the variable in the index like this, okay, what you have to try to do is you have to uh, try to make the bases equal in either side of the equation symbol. So I'm trying to write this as half, again 2x plus 1. We know that anything raised to the power 0 is 1. So instead of 1, we can write anything here and raise it to the power 0. Any number and raise it to the power 0. So I just write it as half. I have the freedom to write anything here as the base and raise it to the power 0, and still we get the answer as 1. Again, now you can see that in the left side of the equation symbol you can see half as the base, and in the right side of the equation symbol you have half as the base. Okay, since you have common bases in either side of the equation symbol, you can just equate both the uh, you can equate the indices of both sides. So that gives us the result 2x plus 1 is equal to 0, and then we have x equals minus 1 over 2. So the answer is minus half. Is there an answer? Yes, B is an answer. Z no, D is not an answer, E is not an answer, or A is not an answer. So our answer is B. Okay. The 12th question. Can you give me the answer for the 12th question? This is a similar question to uh, question 9. So please give me the answers of question 12. Answers of question 12. Okay, answers are C. Okay, that is the answer, of course, C. I'm not going to do this because we followed a similar. Okay, anyway, I'm going to do it. Let's see, we have time anyway. 12 x raised to the power 6 into y raised to the power 3 z, and whole thing is raised to the power 1 over 3, and we have x is 10, y is 2, and z is 27. So just substitute these values and you will get the answer. So 10 to the power 6, 2 to the power 3, and 27. The whole thing raised to the power 1 over 3, and you can write 10 to the power 6, again 2 to the power 3. 27 is 3 to the power 3. So just simplify this and you have 10 raised to the power 6 into 1 over 3, 2 again 3 into 1 over 3, and 3. So just like this, you have 6 over 3 is 2. So this is the answer. Answer is 100 into 2 into 3, and the answer is 600. I hope it was clear. Anyway, so answer is C. Then we have question number 13. This is also similar to a previous question that we did. The question number 13. Question 13. Minus 2 plus log of 36 to the base 3. What is the answer? Question 13. What is the answer? Okay, one says yeah, B and C. Thank you. I'm going to simplify this. Minus 2 plus, instead of 36 I'm going to write, how can we write it? We can write it as 9 into 4, right? 9 into 4, 3. So minus 2 plus log of, instead of 9 you can write it like this, log of 9, 3, log of 4, 3. Minus 2 plus, instead of 9 you can write it as 3 to the power 2. So you can bring that 2 to the front. So you have log of, sorry, so this is what you are getting. So this is again 2 plus log of 4 to the base 3. This 2n plus 2 cancels out. Answer is log of 4 to the base 3. Is the answer log of 4 to the base 3. The B is an answer. Is C an answer? First C, A. For A we have log of 9 to the base 3, and you can write it as 2. Okay, so they are here 2, so 2 is not an answer. B was an answer. C given as 2 into log of, right, this is given, so I'm going to write it as a log of, you can bring this 2 here, so that results in 2 to the power 2 to the base 3, and we have log of 4 to the base 3. So C, B is an C is an answer. Is D an answer? 0, no, not an answer. 2 is not an answer. Now question 14. What are the answers? Question 14. Okay, B is an answer. B, I'm going to do it. 14. We have 9 raised to the power half. Again 2 to the power, and 9 raised to the power 3 over 2 into 2 to the power 0. We have, we can just write, we can write 2 to the power 2 and 9, 3 over 2 minus 1 over 2. We have 2 to the power 2 over 9. Answer is 4 over 9. Is 4 over 9 an answer somewhere? B is an answer, okay. A is not an answer. C, no. D is not an answer. E is not an answer. There can be, I'm not saying there is an answer, there can be answer like, let's say 16 over 36, right? Here, when you multiply this by 1, okay, 1 is 1, so you still get 16 over 36. So if there is an answer like this, it is still a valid answer, okay. So they might confuse in the examination by giving you uh, the same answer in different phases, so you need to be careful and write the relevant answers and find the answers, so you need to be smart. So that is why I asked you to go through all the 5 choices. If you notice a direct answer somewhere, just don't write it as the answer and go to the next question. Go through all the 5 choices and get an idea about the answers of each choices, so that you will not lose marks. Because in this maths paper, most of the time you will be losing marks, not because you do not know anything, but because of your negligence. So it's really important that you focus on the question and get the answers. Then last question we have, in the 15th question, actually we had a typographical issue. I think he had written -3 in the front, and I corrected it. One of the students mentioned it, and I corrected it and we uploaded it. So for 15 we have 15 one, 3 plus log of 1 over 64 to the base 4, right? We can write it as log of 1, or we can write it as 4 to the power, right? We can write it like this. Then we have 3 plus, we can bring this 4 to the numerator, right? We can write it as 4 to the power minus 3, here the base is 4, and we can bring this minus 3 to the front, minus 3 log of 4, 4. Now we have 3 minus 3. What is the answer? 0. Is 0 an answer? Yes, D. D is then an answer. So that concludes all the 15 questions of the quiz. Okay. Do you have any questions regarding these 15 questions? Do you want me to explain more? Or are you alright with the explanations? If you want me to explain more, please let me know. I can explain. I mean, if there was any difficult question that you had any difficulties in understanding, please let me know. Please let me know in the chat. It's really silent and no one is seem to be interested in speaking or chatting. So I think I suppose that you have no questions regarding the questions that I discussed up to now. Okay, sir. Yeah, thank you. Thanks for the feedback. Yes, so these are the sort of questions that you will be facing in the examination. So you will not have any issues if you just manage to tackle these questions. You won't have any questions. It's just one thing that I need to say is the same thing that I said earlier. You need to be really careful in choosing the answers, because there are traps. Okay, there are traps, and the same answer is given in different forms, go through all the 5 answers and get an idea about each of the answers before moving on to the next question, because uh, it's really important that you pass this examination. I'm so right. Okay, I think it's 8 o'clock, and I just wanted to give you a basic idea about the topic 7. And now that we have completed the topic 7, and in the syllabus, if you can remember, so this is the syllabus of introductory mathematics. We completed numeric numbers and arithmetic operations, right? And then we completed basic algebra. We completed solving equations and inequalities. Then we have completed about half of the topic 4, fundamentals of measurements. In this particular topic, we have one remaining part where we have to discuss the basics of trigonometry. It's a very simple thing. I mean, what you have in this syllabus is simple. So I will discuss it in a session later. And then we have percentages and ratio. That is a small topic. Then we have fundamentals of sequences and series. So there we have to discuss about arithmetic series and geometric series. You must have had exposure to this in your O-level classes. uh, I think you may have heard of Samantar Shreni and Gunottar Shreni. So those are the two things that you will be facing in this one. And then we just discussed indices and logarithms. And for modular arithmetic, I think UCSC, yes, it's a new topic. So let's get to that once we have the materials. And that's all for today's session. And I would like to do some questions regarding the past papers. I mean, uh, actually, we do not have time now. Let's discuss these past papers in a different session. And if you can, please go through these past papers now. Now is a good time. You have only around, as per the tentative timetable published by UCSC, you have only around 4 weeks from now to complete the examination. So from what we have done up to now, you can complete at least, I think, 10 to 15 questions out of the 25 questions, right? So please go through all the sections where you will find the questions from the topics that we have covered so far. And even if you can complete the answers from other topics, of the topics that we have not covered so far, please answer them. So my advice you to is just keep answering the past paper questions, and you will be good to go once you have a good idea about the structure of the paper. I will anyway be discussing these questions in the future. So once I will let you know about the schedule of the discussions. So in the meantime, please go through the questions and be familiar with them. And also, uh, if you can, please raise a question. Please raise your questions in the WhatsApp group or in the Google Classroom if you come across any maths question, so that I'll be able to answer that. Because if one of you has a question, another student also may have the same question. So if at least one of you can raise such a question, it will be beneficial for all the other semester 1 students. So please uh, do that, and I'll be able to answer that. We'll be able to discuss the answers in the group. So I think that's all for today's session. And I would like to thank all of you for joining in this morning. And yes, I will conclude the session now. Thank you. Have a nice day.